Okay, it tells you that if you form a square on its hypotenuse, the area of this square is equal to the sum of the squares of the other two sides. So this has been proven to you when you were in lower sec. If you go and form 3 squares using the 3 sides of a right angle triangle, the biggest one, the area of the biggest square will be equal to the sum of the other 2 squares. So this has been established for you by Pythagoras theorem, so nothing new, we will use that. And then they tell you that the ratio of the 3 different sides, you could actually do a OA, AH, OH. But if you go and jumble them up, right? In A math, we will always do this kind of thing, right? So this is OA. What about AO? Right? So you will learn in A math that is called cotangent. Okay, because it's 1 out of tangent. So if you reciprocate your tangent, you'll become cotangent. That is reversing the ratio, that's all. Okay, same thing here. What about you reversing the ratio here to be H over A? You flip it, right? You're going to flip this ratio reverse. Then this will introduce secant. Okay? And then if you reverse the ratio OH to be HO, then it becomes cosecant. So in A math, when we go into trigo, you will see cotangent, secant, cosecant. But it is just the same as 1 over tangent, 1 over cosine, and 1 over sine. It is just another ratio they came up with, and then they came up with another function to represent it. Okay, but E math only tua kaso. You won't see cosecant, cotangent, and secant. Okay, you will only see tua kaso. So that's the only thing. Yes. Inverse we will learn principal value, but that is also at a later time. Which one inverse? No, this one called reciprocal. Inverse is like that. When you solve the angle, remember? Do you all remember when you all need to solve the angle, you need to inverse your tangent? This one called inverse. This one called reciprocal, different. Yes. No, inverse means I bring the tangent to the other side. But reciprocal is I divide it.
Because you're putting tangent to the arm.
This one? Yeah, that's why we call it inverse lah. But you're saying this one is it. But this one is a different thing already. Okay, but don't worry too much. We'll explore this very in-depth when we go trigo A math. And there's a whole lump of trigo chapters that will welcome you with love. End of the year and the start of the whole year, next year. Okay, so anyway, this right, I don't think I need to go through. Do I need to? You all can go back do as homework, Picasso, or cannot? Okay, you do now. Run through. As in go through a few, huh? Okay, PQ, this one easy, right? PQ, what do you do? How to find PQ? Yes, Pythagoras theorem. What should I do? Yes, so PQ is 10 square minus 6 square, and then you take a square root. So it is 8. Okay? So this is Pythagoras theorem by PT. Okay. No lah, you spell Pythagoras theorem. You all work harder. I've worked hard already. Okay, next one is if they ask for the fraction in its lowest term. So I want to find tangent of this angle. Instead of using theta, they use x, so no problem. How come become star? Nowadays, they keep detecting weird shapes. Okay, whatever. Okay, so anyway, this is the angle that they are talking about. So how do we identify hypotenuse, adjacent, and opposite? Where is hypotenuse? PR, this one. Hypotenuse is always the longest side opposite the 90 degree. Where is the adjacent side? PQ, this one. Because it's just next to your angle. Okay, and then of course this is opposite. So once you identify your how, right, HAO, then you can start doing your trigo ratio. So tangent of the angle X is O over A. So O is 6. Oops. Okay, O is 6. And A is 8. So give me your fraction in its lowest term. So answer is just 3/4. Okay, don't go and find the angle. So don't tangent inverse and find angle. I just want the ratio. If you want to find the angle X, you will do tangent inverse 3/4. So how to call out the function tangent inverse? You shift tangent, then you key in 3/4. They will give you the answer of the angle. Okay, but I don't want the angle yet. Okay, for now, it's just the ratio. Okay, same for cosine. Cosine X is what over what? Remember your toi, your ka, your so. Adjacent over hypotenuse. So it's A over H. So it's 4/5. Then lastly, they say using your sine X. So using your sine X. So sine ratio is what over what? Okay, so opposite over hypotenuse. So it's 6 out of 10, which is 3/5. They say then you go and find the angle X. So if you want to find angle X, you need to sine inverse your 3/5. So go and press that using your calculator. What is the angle that you get? Leave to 1 dp. Angle is always 1 dp. Yeah, 36.9. Okay, 1 dp. So angles answer accuracy to 1 dp. Okay, if those of you who get a different answer using your calculator, it must be that at the top panel of your calculator is not in the degree mode. It could be in the radian mode, which you need to change to degree mode. At the top panel of your calculator, you should see a D there. If you don't see a D, then something is wrong. You have to shift setup, go to the angle unit and change to degree. So if not, shift setup. Our gradient is in tertiary, so we don't use that in secondary school at all. Shift setup, then choose your angle unit. Make sure it is in degree mode. Okay, you will use radian when we go into arc length sector area in chapter 9. But now we don't need. Okay? So that is Tuakaso for you. And then same thing here. If I want to find X, I zoom into this triangle. First step is always to identify your how. Your H, A, and O. So where is your H in the red triangle? The 28. Always the longest length opposite the 90 degree. Then for your angle here, aiyo. Okay, don't know what happened. Okay, your angle that is here, then your adjacent side will be here, and then your opposite will be your X. So always identify your how properly first. So in order to solve for X, I want to find O, I have H. Which ratio should I use? Sine, because it's so. So sine of the angle, sine is always attached to the angle one, is equal to the ratio O over H. Then the rest is algebra solving. Okay, cross multiply. Okay, 18.0. Length is 3SF. Okay, next triangle to focus on, the green one. So remember, no matter what, when you have a right angle triangle, go and identify the how first. So H is opposite the 90 degree. Since your angle is here, so adjacent side is next to it. And then this part here is your opposite. So you ask yourself, you want to find the unknown angle, you need both ratio of the sides to be known to you. So I have O, I have A. Which ratio should I use? Which one? Tangent, because it's 2. So tangent of the angle Y is equal to opposite over adjacent. So in order to find the unknown angle Y, you need to do a tangent inverse. So when you are finding angle, that's where you take inverse. Okay, when you are finding angle. Okay, you will get 61.8 degree, 1 dp. Okay, last 3 question homework, Ken. It's your Sec 2 work. Okay, this one, the part A is your converse of Pythagoras theorem. So can you do on foolscap paper so that I can see your presentation, see whether there's anything that I need to refine. So question 3, 4, 5, do on foolscap paper. Okay, but if you have already done on your notes, it means you need to tear out for me. But if you do on foolscap paper, I can collect. Okay, so 3, 4, 5, do as homework. I just want to highlight isosceles triangle. Can I? 机会 later I put the notes in my locker when take. Okay. Done? Okay, next one. Isosceles, very important. When they tell you you have an isosceles triangle, the perpendicular line is a very magical thing. If you have an isosceles triangle and you drop a perpendicular line to the base, it will cut the 2 triangles into congruent ones. This one is an automatic fact of isosceles triangle that they don't tell you. It's a hidden property. So if you drop a perpendicular line, straight away, these 2 are right angle triangles. Okay, straight away, these 2 are the same. Okay, and this will be equivalent. You will cut these 2 angles into exact halves. So this is a property of isosceles triangle that you need to know. So it says state the name of the given to the triangle shown above. What is it? What kind of triangle? Yes, isosceles triangle. Isosceles is C-E-L-E-S, not C-I-L-I-S. I have students who spell it wrongly. Okay, size of the angle Y. Okay, my angle Y is up above. It is a combination of 2 small parts. So if I can find half of it, I can find the full Y. So I'm just going to zoom into this right angle triangle. Oh, actually, I just straight away find angle will do, right? Oh, I don't even need this. Okay, good. So I'll just 180, take away 40, take away 40, and that's my Y. 100. So this is base angle of isosceles triangle. But if they never ask reason, you never write, it is fine. I'm just putting it here as a recap.
That's because it's not drawn to scale.
Okay, next one. If we zoom into this triangle 5, 40, and question wants me to find this full length. So that means I need to find half of it first. Okay, let me call this M so that it's easier to find. So if you have a right angle triangle, first thing you do is identify your H, your adjacent side, and your opposite. So I want to find A. This is what I need to find, and I have H. So what should I use? Cosine. So cosine goes with the angle 40 and is equals to BM over 5. So cross multiply. BM is 5 cos 40. Okay, don't need to evaluate using the calculator first because this is not your final answer. Let's keep it as exact as we want. Okay, so now to find BC, I multiply this by 2. So you will get an exact answer that you don't have to lose accuracy marks. So 7.66 cm. Length 3SF. The X is? The X is at the bottom. What do you mean? Oh, we will still cross multiply. That means instead of this on top is at the bottom. You cross. Recently it's crazy. I don't know why it keeps detecting weird stuff.
You cannot press and hold.
Okay, I cannot press and hold. Nonsense. Okay. Okay. Those of you who are asking, what this is the case where we bring up, we should already get the answer, right? But what if the expression is this?
Then don't we just divide that?
You can swap the position of these two, and then to find BM is 5 out of cos 40. So if the expression is this way, then the BM goes up, cos 40, you bring it down to
So
B5.
you just divide cos 3 when you divide
By the 5, yes. 5 divided by cos 40. Okay, so this is if the ratio is inverted. Okay, not in such a neat way. Okay, but this one you can ignore for here. Okay, last one, I want the perpendicular distance, this one. How to find that? That means I want to find O now. I have H. What should I use? What should I use? Sine. So sine of the angle 40 is AM over 5. So AM is 5 sine 40. So find sine 40, which is 3.21 cm. Okay, just now I heard some of you saying I can use Pythagoras theorem. Can. But if you use Pythagoras theorem, please be as exact as you can. That means when I zoom into this triangle, this was 5. Don't use the rounded off figure. Use 5 cosine 40. Okay? So when you 5 square minus 5 cosine 40 square, and then you take a square root, it will also give you the answer 3.21. But if you use a rounded off figure 7.66 and then you go and square it, you go and subtract, you square root again, your final answer will be off 3.21. Then you will lose accuracy mark. So if you want to use Pythagoras theorem, please make use of this original exact number. Then you can get the answer. Okay? So this is isosceles property that is good for you to note. Yeah lah. Can you also do the next few examples as homework or classwork now? So example 2, just do on the notes. Okay, we rested enough. So this is one of the sides of the triangle. So first question, to find BC, I will use Pythagoras theorem. So hypotenuse square minus 1 of the square of one of the sides. and then you take a square root. Okay, so if you press calculator, what is the value that you will get? 12.173. So always give 5 sig fig first, and then you give me the actual 3SF. Yes. E. This is E. Okay, so once you are done with finding BC, next I'm interested in finding the angle ABC. This one. So same thing, I have a right angle triangle. In order to find angle, I need to use Tuakaso. So this is my hypotenuse, adjacent side, and opposite. So if I look carefully, I have O, I have H. Although I've just found A, in case I've made a mistake with A, it's safer to use the two given ones than the A that you just found. So between O and H, what ratio should I use? Tuaka also. O and H. All three can, but OH we use what? Sine, So sine of the angle ABC, it's O over H. So to find the angle ABC, bring the sine over to get sine inverse. Ravan, you ready or not? Ravan, yeah, correct. Ravan. Okay, so what is the answer for the angle? 28.1. Okay, 1 dp. Okay, but good practice to give me 5 SF. What is it?
28.100.
Real, Yeah. Okay. Because you look like you're joking. Okay, so that is the B. So every time it's a good practice to go and put in the value just found. So this is the 173. Okay, last one. I want to find the length of DC only. This part. So that means I don't want to look at the big triangle already. I'm just going to focus on the smaller one. So if I focus on the small right angle triangle, the last one would be, this is hypotenuse, this is my adjacent side, and this is my opposite. So between HA and O, I have O and I want to find A. So OA means I use Teng. Okay, Tuakaso, right? So the toe that he was saying. So tangent 43 degree is O over A. So remember yesterday we were telling you if this appears at the bottom, you can switch the position of the two of them. So DC is 6.5 divided by tangent 43 degree. So press calculator, what's the answer? 6.97 cm, 3SF. Okay? So refer to the correct triangle, use the correct ratio to help you. So this one is the basics, the fundamental unit, where we go into 7.2 and 7.3 and 4. Yes. Chapter 7 is all the formulas. Chapter 8, we go into 3D shapes. But it's using what you have learned in chapter 7 to solve. Okay, so chapter 8 is 3D as well as bearings. Okay, bearings, going for the direction. Okay, let's go to the next example. Raj, you... Okay, or the soft copy is in the Google Classroom also. How like that? How like that? Okay, next one. 3, 4. This one no need to do on the foolscap paper. You can. Example 3. I want to find AB. So if you want to find AB, we can look at the small right angle triangle here. So to find AB, I need to label my how. So H, A, and O. So if I want to find A and I have H, then I will use cosine. Yes, correct. So cosine of the angle 52 degree is AB over 3. So you do a cross. Cosine 52 AB over 3. So AB is 3 cosine 52. What's the value? 1.8. For one more? 469. So 1.85 meters. 3SF. Okay, but when you copy onto the diagram, use the more exact one. So you can change it to 3 cosine 52 degree. Part 1. Okay, next is part 2. I want to find the angle AEC. This one. So when I zoom into the triangle, I zoom into the triangle that has that angle. So it will be this right angle triangle that I'm looking at. So again, identify your how. It will always be the hypotenuse first, which is this one. Okay, the adjacent side. And then finally your opposite. So I have A, I have O. I want to find the angle. Which ratio should I use? Huh? Which ratio? O and A. Toa, to or toa. So tangent of the angle AEC is opposite over adjacent. So in order to find the angle, you do a tangent inverse. Okay? So answer? 198. So 1 dp 68.2. So if you want, you can label it. Okay, last one is the length of DC. So I want to find the length of DC. By right, I should focus on the tiny triangle at the bottom. But in order to find the tiny triangle, I need a little bit more info. So you see, D, C, and E. This is what I want to find. I only know this and I have no angles at all. So I don't have enough info. I must use whatever I'm given to help me find the next unknown. So you take a good look. Is there a way that I can find this angle? Is there a way that I can find this angle?
Yes.
How?
Adjacent and hypotenuse.
Adjacent and hypotenuse. Okay, you are saying about this one, right? H, A, O. Using A and H. But I don't have the length of A. That's what I want to find. But in order to use this pair, I need to have the angle there. So how can I find that angle? 180 minus the 90 minus this one, right? This one I can find. This one is like 38 degree. Okay, which is 180 minus 90 minus 52. So that is 38. So I need to first find ECD, which is 180. Take away the 90 degree. Take away the 38. So that's also a 52, right? Okay, so with this being 52, then now I can use my cosine. So cosine of the angle 52 is A over H. So CD or DC is just 1.2 cosine 52. What's the answer?
0.738.
So small. Okay, 3SF.
And then GSL is 0.739.
Oh, there's one more. Okay. So quite direct scales. Actually, all of this you have learned in Sec 2 already. Okay, it's all the same thing that you have learned in Sec 2. That's why it's called a 7.1 recap. The recap that you have done. The only new thing is if we move into the second quadrant, the obtuse angle. Okay, last example. Parallelogram. A is perpendicular and it meets CD at the produce at point E. So CD produce just means I extend the line CD and they meet at E. So that's what the question is telling you. AE is 8, AD is 10, CD is 10. No, CD is 10 and but here right 12 leh. So which one should we follow? They all use the 12 or the 10? You all use the 12, right? I'm sure you never read the question. Okay, so we change this to 12 then. Okay, then find ED. So they want you to find this. So one look at it, you know, zoom into the right angle triangle, use Pythagoras theorem. So part A, no problem, by Pythagoras theorem, ED or DE is 10 square minus 8 square square root. So it's 6, is it? Good to write by PT lah, minimally. Last time you all spell the whole thing out, right? So 100 minus 64, so 36, 6 lah. Okay? So that's this. So once you know the value, quickly go and write it there so that you won't miss out on the info. Next, you want to find the angle ADE. This one. So to find angle, you can always use Tuakaso to help you. So use the length they give you rather than the one you find. Okay, in case you make a mistake in your calculation. So this is your H, A, and O. We will use O and H. So sine of the angle ADE is O over H. So ADE is sine inverse. What's the angle? 130. So let's call it 53.1. 1 dp. Okay, next they want the angle DAB. This one. So you ask yourself, I have a parallelogram. Parallelogram has parallel sides. So this pair of sides are also parallel. So just now they tell you that actually this line is an extension. So if it's an extension, it's that same line. So can you see alternate angles? So actually, you can straight away tell me that part 3 is also 53.1 degree. Alternate angles, AB parallel to EC. That's it. Okay, so they are the same angle. Okay, then area of trapezium, the whole thing. Can you all still remember area of trapezium formula? Half times sum of parallel lines times the height. So, first thing first, this length is the same as this. They are both 12. Opposite sides of parallelogram, same length. So, 12 plus the bottom base, which is 6 plus 12, so 18. Okay, times the perpendicular height between the two parallel lines, which is 8. So don't choose the wrong one. In Sec 2, some of you may choose the 10. So that is not the parallel side. Must be the one perpendicular to the two parallel sides. So final answer? 120 cm square. So that's the trapezium. Yes. Sum of parallel lines. Okay, so remember this is your trapezium, this is your A, this is your B, this is your perpendicular height. Yes. Go. The counselors go. Okay, so you sum up the two parallel sides and then multiply by the height. They want trapezium. Okay, do you all remember parallelograms formula? How to find area of parallelogram? Same as square, or rather rectangle. Base times perpendicular height, right? So to find the area of this parallelogram, I will use base times the perpendicular height 8. So in this case is 96. Okay, so I have the area of this parallelogram. Why do I need that? Is because it will help me find the shortest distance or the perpendicular distance. So they say I want to find the perpendicular from B to AD. So supposedly here.
Divide the parallelogram.
No need. Actually, this is the same parallelogram that we are looking at. If this is taken to be the base and this is taken to be the perpendicular height, then they should give me the same area. So now the base here is 10. So it is equivalent to 10 times the height that I'm trying to find. So actually H is just 9.6. Okay? So whenever they say perpendicular distance or shortest distance, think about area. Area is a good way to find shortest distance or perpendicular distance. So this is the trend they like to test. Okay? So that is it for, remember, we assuming that this is a unit circle. Unit circle meaning the radius of the circle is 1 unit. That means assuming that this is always 1 lah. Okay, this is always 1 by right. Okay, but in this case they let it be R, the radius. Okay, but later on the simulation that I'm showing you, I'm taking it to be 1 so that you can see it easily. Okay, if I have a point on a circle, I will have the X and Y coordinate. So remember, Tuakaso only works with right angle triangle. So we always draw a right angle triangle from the whatever point that we choose on the circle. So this is the right angle triangle. And this is the angle that is formed. So based on this angle form, this is my hypotenuse, this is my adjacent, and this is my opposite. It is always at the same place. Okay, and then this being my O over A, can you see why they use this to be Y? This length here is Y, right? Your Y value. And this X value here, your A is your X. And then they let this be the radius of the circle, but actually it's just 1. Okay, so O over A is Y over X. That's why they write Y over X. Okay, and then cosine is A over H, so it's X over R. That's why they put X over R. And then lastly, it's your sine, which is O over H. Then it's Y over R. So these ratios that they write here is nothing new to you. Just that when we put it on the grid, right? On the unit circle, they use it as this kind of ratio. Yes. R is the radius of the circle. But actually we can take it to be 1. Okay, so this is, imagine this dot, it can be from anywhere in the circle. And so far we have learned acute. Acute means it stays within the first quadrant here. Here. Within the first quadrant. That means my dot can start from 0, go all the way to 90. Okay, and then I can find all the ratio to be O over A over H, O over H. But what if this dot goes beyond the 90 degree into the second quadrant? Okay, for E math, we are only learning about 2 quadrants. But for A math, we go all 4. That means we go through all one circle, and not enough, we go in revolution. That means we keep going round and round. Yes, okay. So with that being said, goes to this part. What changes is that there are some values that becomes negative. Can you see closely? Okay, we do the same thing. Instead of X, what is this value now? Negative X. But this is still Y, right? No change. Still on the positive side. This one still no change because this is forever radius. It's always positive. So if I look at the angle, if my angle becomes obtuse, become more than 90 degree, what happens to my H, A, O? So we apply the same rule. So my HAO in this case will become what? What is my tangent now? O over A. So my O, no problem, is still Y, but my A is negative X. So can you see that my ratio become negative for tangent already in the second quadrant? Okay, and then cosine is A over H. So my ratio becomes minus X over R. So again, the ratio is negative now. Then my very last one is sine, which is O over H. Can you see that the ratio is Y over R? So it's positive. So I want you to make a good correlation between the acute ones and the obtuse ones. Is there a difference in the ratio that you found?
Yes.
What?
Tan and cosine.
Tan and cosine is negative. So can you see every value is exactly the same. No change in the value, but the sign is different for cosine and tangent. But okay, let me just show this one so that you can see that it's a bit different. And then for sine, it is both positive. There's no change. Yes. Acute angles better. There's no better angles lah. But just telling you that when we are stuck within the first quadrant, your cosine, sine, and tangent ratio is always positive. All three are always positive. But once we go into the next quadrant at the obtuse part, the sine still stays positive because my y value and my r value is the same. They are positive. Okay, but my x value becomes negative. So those ratio with my adjacent side will be affected by becoming negative. So can you see that? Okay, but another thing I want to point to your attention is this one. Why did they use 180 minus theta? Why did they use 180 minus theta? This one I use theta, no problem. Why this side I use 180 minus theta? Why? This theta is obtuse, right? When the theta is obtuse, that means more than 90 degree, you look. It's bigger than 90 degree, right? But when we are referring to the right angle triangle. So what is the angle in the right angle triangle that we are using? To represent this, can you see that this angle here is 180 minus theta? Instead of writing it as theta, we'll write it as 180 minus theta. We always put in a smaller value. But with that being said, don't need to be confused about it. When you see obtuse, which are the two ratios that will become negative? Tangent and cosine. So sine will stay positive. Okay, I just want this. I ask you all to compare these two. Obtuse and acute, how is it related? How is this cosine related to the acute one? Yes, so the ratio is the same, but just add a negative sign in front only. Okay, so they tell you that sine of P is 3, 5. Okay, this is the angle outside. But just now we learned that sine of P actually is the same as sine of 180 minus P. This one we learned already just now. The ratio is the same. They are both 3 out of 5. So this is O over H. So we ask ourselves, this one is H, A, O. So O is 3, H is 5, A is 2, 4. Because you use Pythagoras theorem, right? 5 square minus 3 square square root, you will get 4. So actually this is 4. This one you can find lah. Okay, so now with that, can you find what is tangent 180 minus P? This is 180 minus P. What is tangent 180 minus P? O over A. What is O? What is A? Just like that only. It's the same thing, just that now they will use obtuse angle to confuse you a bit. Okay, but the ratio is the same. It's still O over A because we are talking about this acute angle. Okay, next one. What about cosine P? So remember, this P that we are talking about is the obtuse one outside. The obtuse one. So how is this related to the acute answer? Just now we say, right? How is this the same as the acute answer? From the first page, just now we had this. Just add a negative sign in front. So cosine P is negative cosine 180 minus the P. Because this is acute. And this is the obtuse one. So just now we established that the obtuse one is negative of the acute. So how to find cosine ratio? What is cosine? A over H. So A is 4, 5. So just with the negative sign. So it's the same way as how you find originally, but just add a negative sign. Okay, same thing, tangent P. P is obtuse. But I want to relate it to the acute one. So just now on the first page, we know that tangent obtuse is negative tangent acute. So this is the acute one. So same triangle that I'm referring to now. Tangent is O over A. So it's 3 over 4, but with a negative sign. So just remember same ratio, but add in the negative sign will do. Yes. Question you will see for O level. This is an O level question. They ask you to find the theta when sine theta is 0.34. Okay, let's look at question 2 then. They give you a right angle triangle, and then they give you some length, and then they say, can you find sine of x? Okay, sine of x is a ratio. Remember that. So sine of x is O over H. So go and look at the right angle triangle they gave you. It's always the right angle triangle. So this is H, A, O. So my O over H, before I can do that, I need to use Pythagoras theorem to find O first. So to find O, why my pencil suddenly so thick? Okay, so it will be 13 square minus 12 square root. What is that? 5. Oh, 5. So since I know this length is 5, then the sine ratio here will be 5 out of 13. That's all. Don't go and find the angle x. I don't want. I only want to know the ratio. So give me 5 out of 13. So that's A's answer. Okay, part B is a bit different. I want to find cosine of the angle PRS. This is the obtuse angle. So remember when we were at the second quadrant, it is obtuse, you go into the second quadrant, you still look at the acute triangle beside it. Okay, you still look at the acute triangle beside it, just that the ratio might differ a bit. So if we look at the triangle next door, so this one, although it's this angle we are talking about, actually we are looking at this right angle triangle. Okay, so take note, I want to find this is the same as finding negative of the cosine angle beside it. This is the key. Can you see? My cosine 150 is negative of my cosine 30. It is just negative of the ratio. Because they won't reflect the negative here, you have to add it in on yourself. Imagine that that thing is on the second quadrant. So the only difference is this one was cosine 30, but when I try to find cosine 150, okay, it is negative of my cosine 30. So same thing, when I'm finding cosine of PRS, it is negative of the cosine of PRQ, the one next door, but you add a negative sign. Okay, so to find the answer, it's just A over H, so it's 12 over 13 with the negative sign in front. So that's the only tweak that you need to be comfortable with. Yes. Okay, see, PRS is this obtuse angle. So I'm interested in finding the angle beside it, which is the acute one. So same thing, when I was 150, I go into my second quadrant. But I cannot find the ratio using a non-right angle triangle. I have to look at the ratio beside it. So the relationship for cosine 150 when I'm looking at the triangle form, it is negative root 3 over 2, which is negative of cosine 30. Can you see? This one is negative of my cosine 30. So the relationship between cosine 150 is equal to negative cosine 30. Just add the negative sign in. You will get the same value. Essentially, they are all root 3 over 2. But just that if you go into the second quadrant, there is a negative sign in front of it, that's all. Because in that quadrant, my A value has changed to a negative one. Yeah, so the ratio changed. Just that when we are drawing here, we cannot reflect the negative. Yes.
How do you get opposite this by
Pythagoras theorem. Yeah, Pythagoras theorem. Okay? Okay, next one. 90 minus x is this angle here. So it's an acute. No need to look at any other quadrant. So this is my acute angle. So remember, you label your how. So this is hypotenuse, adjacent, opposite. When your angle changes, your how changes. So what is the tangent ratio now? What is the tangent ratio? What is tangent 90 minus x? What is O over A? No, look at the blue one.
Oh yeah.
12 over 5. So the only difference now is I'm no longer looking at x. I'm looking at the blue angle now. So my hypotenuse is still the same, but my adjacent side changed because my angle has changed from here to here. So my O over A is 12 over 5. Okay? Next one. Okay, it will get better. Okay, show that BD is 13. This one no problem, right? It's just Pythagoras theorem by PT. 12 square plus 5 square square root. So that's why you get 13. So this one no problem, shown. Okay, now I want to find the ratio. So tangent BDC, when it's acute, you're happy because you're just referring to this. You don't need to care about sign. So tangent is O over A, so you will get 12 over 5 for the first answer. So this one clear cut. If it's acute, it's always very direct. Okay, next one is BDE. Yes. No need. You can leave it like that. Okay. Then BDE is the angle next door. Oops. Interested in now, the black one. So remember, obtuse we must link to the acute, right? But for sign ratio, it doesn't matter. It will be the same as the sign of the acute beside it. Remember that? So sine 30 and sine 150, they are equal. So no need to add the negative. Yes?
What if you write this sine bracket 180
100?
180 minus
Also can. Also can. Okay, so it's the same answer. So it's just 12 over 13 over h. Okay, 12 over 13. No problem. No need to add negative because in the second quadrant it's the same thing.
So the sine acute angle and sine
Obtuse,
is the same.
same ratio. Okay, last one, ABD. ABD is here. This one. So it's an obtuse angle. You need to relate to the acute beside it. So the blue one, you need to relate to the green one. So like label your H, A and O. So I'm interested in cosine. So remember, cosine of obtuse is negative of the acute. So add in a negative sign. Write down the angle beside it, which is DBC. The green one. And then it will give you A over H. So 12 over 13. But add a negative sign. Okay, so that's the only difference. When it's sine, it doesn't matter. When it's tangent and cosine, it matters. We just label. Okay, if you don't want to label this, you prefer to write it as 180 minus angle ABD also can. Okay, if you prefer to write that. B part 3. Okay, cosine of the blue angle is the obtuse one. So I need to relate to the acute beside it. So cosine of the blue one is negative of the cosine of the green one. So that's why I write this one, this statement here, before you sub in. So it's just like cosine 30 is negative of cosine, cosine 150 is negative of cosine 30. No need, because this one is not on the grid. But actually on the grid we know that this is the behavior. So we use the result to apply to this. Yeah, yes.
Can it also be written as cosine 30?
Can it also be negative cosine 30 is cosine 150, can. Same. Yeah. Okay, next one. If they don't draw the triangle for you, you can draw your own, no problem. Okay, depending on what they want. So they want BPC. Okay, so this is the triangle, sorry. BPC. So the angle is this one. The angle that they are identifying is this one. So tangent means H, A, and O. So tangent is O over A. You go and read the coordinate here. So this one is minus 14. This one is 10. So it tells me that O is 24 units from negative 14 to 10. And then your A from 4 to 14. So that's a 10 units. Okay, H I can't read. I have to use Pythagoras theorem to help me. So 24 square plus 10 square. Then I take a square root. It gives me a nice 26. So my H is 26 units. So I can find the three sides by reading the values on the grid. So now tangent BPC is O over A. So it's just 24 over 10. Okay, simplify it always.
What's the little arrow?
What error?
Arrow.
Oh no, I'm just saying that
The CPA, BPC.
it's equivalent. I can write this as this instead also can. Oh, what is this cap called? It is the same as angle BPC. And angle BPC, also correct. So it's just a different way of representing, yes. Even if they don't write, it will be in a fraction form. But if you give me decimal, I will accept. Yeah. So instead of 12 over 5, you give me 2.4. If they never say write as a fraction, I will also accept. Okay, because question never say must leave as fraction. Then decimal is accepted. Okay, next one, tangent CPA. CPA is here. Is the obtuse. So what is the acute beside it?
Like a marking on
Marking on top. This one is the angle. It's a symbol for angle. Yeah. Okay, what is CPA, tangent CPA? No need, because I'm not finding the angle. I'm finding the ratio. So what is tangent CPA? I want tangent of the red one, the obtuse. So I should look at the acute, but add a negative sign. I already found from part A that the acute is 12 over 5. So I just add a negative sign only. Don't even need any working. Just put a negative sign to my first answer. Okay, because traditionally the red one is negative of the black one. Ashriel, Marius, and Rishan. Very heated discussion. Where Ashriel you show? Only got one screen and tell me your homework is there. Okay, last one, area of APC. So this one, don't need to think so much. If I'm interested in finding the area of this slice, the yellow triangle. Just give me the half times base times height will do. Don't need to think so much. This is the base. From 14 to 22 is 8 units. Right? And then the perpendicular height is here. 24 units. So you just give me your half times base times height. When it's on the grid, it's always very easy. So it's 96 units square. Okay? So this is part C. Yes. APC not right angle. So I rely on the acute beside it, the right angle triangle here. So this is the acute angle, right? This is the obtuse angle. I will refer to the acute beside it. So tangent of this is negative tangent of this. So I look at the triangle below, the blue one, to help me find the ratio. Area, just use half times base times perpendicular height. You tilt the shape. Yes. Isn't it what? 26. No, it's from 14 to 22. I only want the yellow triangle area. So the base is from 14 to 22, which is 8 units only. Then the perpendicular height is here. Yeah. So you all must see the triangle in this way. If I take this out and then I turn it, it's not right angle, but you use base times perpendicular height. So can you see there is this base times the perpendicular height? Yes. So it's like as if it's like that. So base times perpendicular height times half. Okay? Can So that's question 4. Let's look at the next one. Because obtuse for tangent is negative. Yeah, so you just add in the negative sign.
Just find the ratio, then you see the
For the acute, then yes, correct.
How do you figure out
How do you figure out?
the quadrant?
No, when it's obtuse, it's in the second quadrant. Because it's more than 90 degree, ma. Yeah. Okay, next one. This one. Quick one. I have a ladder leaning against the wall. Given that sine of x is 5 over 13. Okay, take note. Sine of the obtuse is the same as sine of the acute. This one is equivalent. So it's like as if they tell me that the sine of 180 minus x is also 5 over 13. So I go to my right angle triangle and I label my H, my A, my O. They tell me that O is 5 units and H is 13 units because this is O over H. So with that ratio, I can find my A. So 13 square minus 5 square, square root, 12. So this part here is 12. So I know all 3 sides already. Now question say, can you find tangent ABC? That means this one. So no problem, right? I already have my 3 ratios. So what is tangent ABC? 5 over 12. No negative, no nothing because it's acute. It's always positive. Okay, next is DCB. This one next door. This is obtuse. When you are given an obtuse, look for the acute next to it. And then label your how. So H, A, O. So with the cosine ratio, what is the ratio of DCB? What is cosine DCB? Negative 5 over 13. Because this is A, this is H, but because what I'm truly finding is the obtuse beside it, you need to add a negative sign in front of it. So that is it. You find Tuakaso the same way, but if it's obtuse, add negative for cosine and tangent. Okay, add negative for cosine and tangent.
This is quadrant 1.
Yes, quadrant 1. Okay, sine ADE, quick one. This one is obtuse. Which one do I look at? ADB, this one. I should look at the acute next to it. So the right angle triangle, I focus on is this yellow one. So I want sine, right? Sine is H, A, and O. So what is this answer?
7/25.
Yes, that's all. Done. Okay, next angle I'm interested in is ACD. This one is obtuse. So which angle should I look at? The one next to it, which is acute, this one. So I'm going to focus on the blue triangle now. So label your H, A, and O based on the blue. So H, A, and O. Tangent is O over A. So I need to have A first. How to find A? This one. I use Pythagoras theorem. So I'm going to use A. I don't have enough info. Oh, I can use the big yellow triangle. 25 square minus 7 square square root. Is it a nice answer? Oh, it's 24. So very good. This is 12, 12. Okay. So knowing that, I can find tangent already. What is it?
7/12.
Okay, but take note, because I was originally finding the red one, I need to add in a negative sign. So remember, whichever obtuse, find the acute beside it. If it's obtuse, add a negative sign for tangent and cosine. Okay, so it's quite standard. Okay, next one. BAC. This angle. So H, A, O. So acute, no problem. What is the sine ratio? What is the sine ratio?
6.
Oh, this one is 10 for your info.
6 over
6 over 10. So give me 3, 5. Okay, what is cosine ACD? The one next door. So I look at the acute beside it. So H, A, O. What is the cosine? Negative 6 over 10. So negative 3 over 5. Area of ACD, half times base times height. The base is 10. The perpendicular height is 8. So half times 10 times 8. So 40 units square.
Wait, you said these kinds of questions, right?
This is the standard question for Pythagoras. For trigo ratio. Okay, the only one that it was horrendous is this one. You all forgot how to use converse of Pythagoras theorem. So I just write it one time here. Converse of Pythagoras theorem, you look at the triangle they want you to prove. Always start from the longest length. Ravan listening or not? So start from the longest length. AC square is 13 square, which is 169. Okay, then go and sum up the squares of the other two sides. So you have to write this, an square plus nc square is 12 square plus 5 square. You are supposed to prove. So you cannot tell me straight away 12 square plus 5 square equals to 13 square. That's not proving, you're just stating it. Okay, so 12 square plus 5 square is 169, which you realize is equal to AC square. So if you can establish this equivalence, then you can quote by converse of Pythagoras theorem. By the opposite direction of Pythagoras theorem. Okay, since you have proven that the sum of squares of the other two sides is equal to the square of hypotenuse, therefore angle A and B is 90 degrees. Okay, so this is the standard proof. It's 2 marks in O levels if they ask you. So prove it the right way. Yes. Can.
The figure is throwing it off.
Okay, once you prove the right angle triangle, quickly go and write down. Then you can use your Tuakaso already. Okay, so a quick one. ABN is this acute? Look at the big triangle, the blue, the gray one. So HAO. So what is tangent ABN? What is tangent ABN? The grey triangle, what is O over A? 12 over what?
12 over 11.
Not 11, 16.
Yeah, 16.
So you give me 3/4.
4, 3.
Yeah, 3/4. Okay, as a fraction. ACB, this is obtuse. So look at the one beside it. This one. So this is H, A, and O. So what is the cosine of ACB? What is cosine ratio here? 5 over 13. But add a what? Negative. Derivation of the formula for area of triangle is if you choose any of the side to be the base. For example, A, you choose it to be the base. Yes, the binomial second quiz is good, so I don't really need to worry too much about that. Okay, so half times base, which I've chosen it to be A, and then the perpendicular height, I need to leave my formula in terms of the ABCs that I have there. So I'm going to use Pythagoras theorem to help me. So this is H, A, and O. So in order for me to find find O, and I have H, right? I will use sine of angle C, which is H over B. Correct. So if I simplify it, actually my perpendicular height is B sine C. So if I put my height here, so it's B sine C. So this is the other formula for finding area of triangle. So that's how they derive it. So if let's say I choose the base of my triangle to be this, and then this is my perpendicular height. So I'm going to zoom into this triangle and use Picasso to find height. Yeah, and then if I do that, height is actually B sine C. Yes. Can. Okay, so this one, it is just a repetition. So actually, we have found sine C is H over B. So H is just B sine C. That's why you can plug this in.
Can you give us a long note first?
I will give you all tomorrow. I'll see you all for double period tomorrow.
What do you give
What do you write after science?
Where got sine C equals H over B. So this is the formula that we use. But actually, right, if you decided to change the base, let's say I pick this to be my base, then my perpendicular height is probably somewhere here. Oops. See, I back. Okay, can. So this is my perpendicular height. I will still be able to find the formula. Wait. If I follow the triangle, sorry, this is C, this is B. Okay, so if I choose this to be my base, I will also use half times base times the perpendicular height here. So how can I find that perpendicular height? Same thing, I will make use of this angle A. Okay, and then I want to find this. So using my H, A, and O formula, sine of angle A is H over B. So H will be B sine A. So no matter which side I choose, you will realize that if I choose the other two sides B and C, then the angle for the sine is A. So I can use any three sides. Yes. Because these are the two known lengths to me. I don't have this length. So if I want to use cosine, I need Pythagoras theorem first, and then I'll end up having a very complex relationship. So this is the easiest. But anyway, this is the derivation. What I'm trying to tell you is, When you are given a triangle and two sides of the length are given to you, okay, what you are interested in is the angle in between the two sides. So if let's say this is I don't know, 48 degrees, so in order to find the area of this triangle is always half of the product of two adjacent sides. So half, oops, yeah, half AB and then sine of the angle in between them. So this is always the formula. If I change the other side, let's say this is 13 and then I say this is angle 52. Okay, then to use the same formula, it will be these two adjacent sides right now and the angle in between. So they should technically be able to help you find the area of triangle. So no matter which corner, which vertex you choose, it's always the two adjacent sides and the angle in between. Yes.
Actually, you need like SAS, like.
Yes, you need a SAS. Correct. Okay, so this is how we apply the formula. The derivation is as such, but the formula you must know how to apply. So can we still copying, huh?
Yes.
Yes, so where the two sides are given, you choose that corner. So any formula is always that two sides and the angle in between.
How do you know which?
Depends on question, give you what angle. The question will give you some info. Okay, so we see how to apply. So let's say this is the question. Yes. Always sine. Okay, so in this case, yes. Sorry? Yes, the two sides must be adjacent. So like I mentioned, these are the two adjacent sides. And I have the angle in between that is given. So to find area of this triangle, it's half of the two adjacent sides followed by sine of the angle between them. Yes. Between the two adjacent sides. So it must be like a V. Okay, the two adjacent sides and the angle in between. So it's always like that. Correct, included angle. So what's the value you get here? 18.155, so 18.2 lah. Okay, 3SF. Okay, next, they give me the reverse. They give me the area of the triangle instead. So let's say this is my triangle. I don't know how it looks like, just ABC. Okay, and then this is 9. This is 7. So clearly it's adjacent side. So the angle I find would be ACB, which is the angle they want you to find. Okay? And then they say that this area must be 28. So using the formula, half of the two adjacent sides followed by sine of the angle that I want, which is ACB, is equals to 28. So all you need to do is to solve for the angle. So this is what? 63, 31.5. Okay, I don't know. You calculate, I don't have calculator. 31.5. Okay, this one you calculate. Okay, if you don't want to calculate first, you 28 divide by half, divide by 7, divide by 9. Okay, then you get this fraction here, right? Then take an inverse. So what's the answer? 62.7339. Okay, but take note, you read the question carefully. They say possible values of the angles. What do you think I need to do? Do you remember sine ratio? We always have two possible angles that gives the same ratio. So you need to find the 180 minus this also. There's two possible answers. So one is 62.7. The other one is 117.3. Both 1 dp. Okay, because we can assume that the shape looks like that, but the shape could also look like this. So it could be an acute angle as obtuse angle as well. Remember we did sine of acute and sine of obtuse. They always have the same ratio. So this is the same thing. So there are two answers that will give you the same ratio, the acute and the obtuse one. So let's say this is obtuse and this is the acute one.
Wait, why is it like that if it's AC? Isn't it acute?
So this is how we draw. But actually it could look like this as well. So it could be a diagram that looks like that. The other possibility is it looks like that. So it could be an acute or an obtuse one. So two possibilities. You have to consider both. If they already give the diagram, then according to the diagram, acute or obtuse. Yeah, so you can just find one.
Is there two more possibilities?
No, that's the only two.
Her informs
For sign positive, no, the sign all negative.
Yeah.
So don't have. We only want sign to be positive here.
Oh.
Yeah. Okay. So next is a regular hexagon. Hexagon got how many sides? 6. So regular hexagon means 6 sides and all sides are of equal length. That's what regular hexagon means. And is inscribed in a circle of radius 6. So that means if this thing is like, okay, I cannot draw a perfect circle, but inscribed within a circle, and then the radius is 6. That's what it means. Okay, so find the area of the hexagon. So what do you think we can do? So if I were to draw out the triangles it forms, if I can find one of it, I can find all 6. So how can I find the area of this one triangle? This is the radius, right? So this will be 6 and 6. Can you have the angle in between?
60.
How to get 60?
180 divided by
360 divided by 6. Because one full circle is 360, one of the triangle will be 60 degree. And then, if you observe carefully, if this is 60, isosceles, beyond that is an equilateral. Because all 60. Okay, but never mind, once we have these two, we are done because we can find one triangle. So area of one triangle is just half AB and sine of the included angle. Okay, so go and find that. So if you want, you can leave it as it is first, like 18 sine 60. Don't evaluate first. Yes, always sine for area of triangle. The formula is always sine. So to find the area of the hexagon, you times the whole thing by 6. Okay, 3SF. What's the answer? 5, 3, so 5 lah. Okay, so next they say that PQRS actually is a parallelogram and it has the same area. So that means this area is 108 sine 60. Use the more exact one, okay, when you are calculating. So if you want to find the area of parallelogram, what should you do here? What can you do?
Give me equation. Like x
X times x equals to?
x 100.
Okay, think how can we find the area of the parallelogram? First, half A plus B height, that one is trapezium. 2x times x. If you want to find area of parallelogram, it has to be base times perpendicular height. But I don't have the perpendicular height here. Which one? Go and find. Okay, divide this into 2 triangles. Okay, and then for 1/2 of it, you can use the area of triangle formula. So go and find half times x times 2x, the two adjacent side, followed by sine of the 110. So this is for that green triangle. If I want the whole parallelogram, the whole thing what? Times 2. So you get the full parallelogram. So this one here is that triangle you see. So if you times 2, then you get the whole thing. And you know that this will give you your same area. Okay, so go and simplify. The half and the 2 cancels out. Okay, we have a 2x squared here. Okay, my mission is to find the x, so I keep the x squared here, everything else divide over. So to find x, just take a square root. So what's your answer? The answer? 7.05 cm. Okay. So area of triangle formula is very direct. Yes. By right, you will have a -1 which you reject. But because you know x is length, you can actually give me the positive one. But you need to show me that you know there's 2 lah. Yes. This one I calculated. I just simplified so that I don't have to have a long string of number. Okay, some of you sometimes, right, you go and press calculator, you get a long string of number, then you keep copying the long string of number, right? But if you copy this as 108 sine 60, there is meter for you to bring over. I have seen working of long string of number everywhere that you carry wherever you go. It's still correct, but it's very tedious. So you just have to copy the actual value down. It makes your work neater. Okay, so that is it.
What scenario can put the negative sign?
If they never relate to area, it is just a normal quadratic expression, then you need to give me both answers.
Like if they give a scenario, for example, like the depth is negative.
Then cannot be negative. That cannot be, depth, if it goes underground, underwater can be negative. Yeah. Okay? Can I? Before I introduce that, let me give you some shortcuts. Okay, I'm gonna give you some shortcuts. So, first thing first. Okay, the naming convention of a right angle triangle. I believe you were taught when you learned Pythagoras theorem. If this is angle A, the opposite side, it's length A, the small letter A. If this is angle B, the opposite side, we represent by using small letter B. And then this angle would represented by a small letter C for length. So small letter is always representing length. Capital letter is representing angle. So that's number 1. Okay, second thing. We know that if there is a very fast way for you to find without using Tuakaso. You can just memorize it in this way. So first thing first, if let's say I've identified this angle, so this is H, this is A, this is O. So if I want to find sine A, sine of angle B, sorry, so it will be what over what? It will be what over what? Okay, B over C. Okay, so which means to say that the length B is actually C of sine B. So this is a quick way of finding the length of this. This is represented by C of sine B. Okay, then how do I find the other one? So for instance, cosine of the angle B, what will it be?
A over C.
A over C. So to find A, it will be C cosine B. So this is a very long way to find the length you want. But there is a shortcut. Okay, so I want you to see that in a right angle triangle, your hypotenuse can help you very quickly find the length of the base and the height of the triangle. So what happens is this. Can you observe carefully? This hypotenuse is always used to find your base and your height of your triangle. And the bottom, the base of the triangle is always cosine of this angle. And then the height of this triangle is always sine of the angle. So I give you an example. If I give you a right angle triangle and I tell you this is 5, okay, I give you this angle to be 30 degrees. Can you very quickly tell me what is the base of this triangle? 5 cosine 30 degrees. What is the height of this triangle? 5 sine 30 degrees. Then you don't have to go through Tuakaso. You just can give me directly. So this is a very quick shortcut that you can use. If you are physics students, very soon you will learn resultant vectors. When you want to find resultant force, this is also one way that helps you to get the horizontal and the vertical force very quickly.
How about tangent?
Tangent is not required for the base and the height calculation.
It's just like the sine and cosine.
Yeah, not sine and cosine rule, but this is a quick way for you to find without having to go here, manipulate, and then find. You can just, oh, the base is just this, the height is just this. So this saves you some time. But if you are unsure, go back to this. It always works. Okay? So just showing you that. Okay, anyway, just now, right? Area of triangle. Okay, area of triangle. Just now we realized, right? Actually, if I want to find area of this triangle and I choose this side, is half AB sine C. Correct? But I can also choose this side. So this side is half AC sine B. Or I can choose this side. Half BC sine A. So no matter how I jumble the letters, this will help me find the area of the same triangle. So technically they are equal.
Oh,
Correct?
the sine.
It's on formula sheet.
Yes, this is on the formula sheet. Okay, so the magical thing is this. Mathematicians like to play around with symbols, right? So they start simplifying. And then they say, oh, let's try to find a pattern. So probably I keep my sine C here. Then I bring my C down here. So sine C over C. Okay. Then I have another one. I have a sine B here, right? I keep my sine B here. I keep my sine A here. Then they think, oh, this one I bring down and divide. Then this one is sine B. Okay, then the A, whichever I compare with, I can bring the A down, right? So they realize that, oh, there is a pattern. The ratio of the length and sine of the angle is always the same for all the triangles. So that means the ratio between the length and sine of this angle is always the same as the ratio of this length and sine of this angle. The ratio of this length and sine of this angle. So when they realize that there is this formula, they call it the sine rule. So that's how they derive the sine rule. So that means area of triangle, we find area, right? By sine rule helps us to find unknown length and angle. Yes.
Isn't there an extra like
Oh, when we compare, we always compare two only. So between these two, you bring the C down, you bring the B down, the A cancels out. Then you compare these two. I'm just putting them all together.
but then if the A cancels out then you compare
For this one, for these two. But they are equal anyway. So I can compare this pair. Then the C cancels out, so I bring the A down, I bring the B down.
so the A stays then it
Correct. Yeah. So this is how they derive the sine rule. Okay. So how to apply the sine rule? I don't have time. Okay. So sad. Okay. But anyway, this one. Yes.
What's the no tangent rule?
Because it compares with that two length that doesn't help you find your unknown. Yeah. Okay. Okay. Then it's sine rule already. So I just you just see, I don't need to do. Okay, first, remember just now sine rule says that the length
Compare the ratio.
and the sine of the angle is one ratio.
Compare ratio.
Correct. So if I have sine of this ratio, I must compare with the length opposite. So I can find AB by comparing ratio. So for example, this is the ratio I want to compare. So I know that AB compared with sine of 45, this ratio is always the same as this pair of ratio.
with this one.
Yes.
So it's safe for
Same for all three. Okay, so this 100 and sine 60. So if I know, I don't even need the third pair already. I just need one pair to be able to solve for unknown. So I'll keep the AB here to solve. And then I cross multiply my sine 45 over. So the rest is just calculator's work. So sine rule helps you to find unknown length or unknown angle if you have at least one pair given to you. Okay? So with that, AB is known to you already. Okay? So once you know AB, you can find area. So once you know AB, you know this length already, you can always find half AB sine C. Can you find the angle here? Can you find? So half AB sine of the angle in between, done. So this is trigo question. First one, they can ask you obtuse ratio. Second one, they ask you to use sine rule to find one unknown length. Third part, they ask you to find area of triangle. Okay, so this one we will continue tomorrow. But if you want, you can go back and try this part. Oh, before can. You need this, is it? Or you need that? What should you get? Sine 60. 81.64966. So 3SF 81.6 meters. Okay, so finding is not difficult. As long as you appreciate how they came out with the rule, then using the rule shouldn't be a struggle for you. Okay, next one. Every time you find an unknown, quickly go and write in the diagram because you will always forget that you found it. Okay, next, I want to find the area of this triangle ABC. So remember, we need to have two adjacent sides and the angle in between to be able to find area. So this one, I don't have BC, cannot use. This angle cannot choose, right? Okay, I don't have BC, so I cannot use this to find area of triangle. So I'll use my last pair, which I have my adjacent side. So the only thing I don't have is the angle in between. But can I find?
180 minus.
They want what? Okay, so since they want BC, never mind. Let's not work on this ratio. We will need to work on this ratio. So BC over sine of this angle. What is this angle? What is angle BAC? 180 minus 60 minus 45, so 75. Sum of angles in a triangle. So some of you will say, need to write the reason or not? If the question never write, no need. But it's a good practice. Yes. This one is page... Ayo, it doesn't write the page number. There's no page number, is it? You look under sine rule 7.2. Example 1. Okay, so sine of angle 75. So we will do the same thing, cross multiply this. So instead of 45 is 75. Okay, change the answer. So we are not finding B's, we are not finding AB, we are finding BC. So sine 75 times 100 divided by sine 60. 111.5355. Yes. Because this is the known ratio that I have. I have one pair of ratio given to me. Okay? So answer will be 112 meters. 3SF. Okay, then of course, since I have the length, I have 111.5355. I have this adjacent length. I can find the area of triangle. So half adjacent side and then sine of the angle between them. So area of triangle formula is the easiest. You just have to pick the letter V. Okay, and put in two adjacent side and the included angle. Amishi, what happened? So 3943.376. So 3 significant figure, 3940. Okay, in the event that usually when the answer is not exact, we will round off to 3SF, right? But when you are confused, don't know how to round off, give me a more accurate answer than 3SF. We will still mark you correct. Unless the question say die 3SF, or like this case, then you must give me this. If they never say, you can actually leave your answer this way. You will still be marked correct.
When they say in the front page, 3SF.
They will say non-exact answer, leave to 3SF. Okay, but if you give me more accurate, I won't penalize. But if the question specifically mentioned here must be 3SF, then I have to penalize. Okay, so this is how you apply sine rule. Always find the pair, the ratio. Really? Have to wash face. Report too early. Okay, so remember, this one is part A, this one is part B. Can? Okay, next example. Oh, not yet, not yet. So if you want today when you go back, right, go and put the derivation down in your notes somewhere so that you can remember how it's derived. All three formulas. Which one? Sine rule, cosine, and area of triangle. Yeah. Okay, done. Done? No protest. Done. Okay, this one. Okay, I want to find the angle XZY. XZY here. So remember to use sine rule, you need to always have two pairs. Right? So the first pair is given to you already. One pair. The angle and its opposite side. So the angle that they want you to find, I also have its opposite side. So I can now establish my sine rule. Okay, just now I put the length on top of the ratio. But because now my unknown is the angle, I'm going to put the angle at the top of the ratio. So that it's easier for me to manipulate. So sine of this angle xzy over the opposite length. This is one pair. Okay, the other pair, it will be sine of 74 degree. Don't forget your sine. I've had students who forgot the sine and just multiply by angle. Okay, so once you have that, your ultimate goal is to solve for this angle. So I need to get rid of the denominator here by cross multiplying. So I'm going to multiply the 15.8 over. Okay, but I want to find the angle only. So what do you think I need to do? Inverse. So this one I don't want. I want to bring over to the other side. So I will sine inverse this whole thing. So that will arrive me at the angle. Yes. Doesn't matter. So if like when we compare two ratio, right, we say AB is equal to CD. We can also say B over A is equal to D over C. We can reverse the ratio. No, doesn't matter. Okay. So go and calculate that. So as long as you know the sine rule, how it applies, then substituting, I don't think you should struggle with that. So this is 32.329, 1 dp, so 32.3. So everything that you have found, quickly put in your diagram so that you won't forget that you have found it. Okay, then how to find area then? Which V should we choose? Which corner should we select so that we have two adjacent sides and the angle in between? Which pair? XYZ, this one. Because I already have the two adjacent sides, all I need is to find this angle, which I can find easily. So angle XYZ, I use 180 minus 74 minus 32.329. 671. Okay. So once you get the angle, you can use the area of triangle formula already. Half times 2 adjacent side multiply by sine of the included angle. So 3SF 215 cm squared. Okay, remember when you always use the answer from earlier part, use the more accurate one. At least 5 significant figures.
Why did you find XY?
Because in order to use half AB sine C, I need this included angle. If I use this side, I need to have this adjacent side, which I don't have. Unless I want to apply sine rule and find the other side, then I can use this. Because now I can conveniently use these two sides, I must choose this angle. Yeah. Yes.
Can we just put 60 because we already have the information that's
Can. So angle ABC, right? If you observe carefully, this is isosceles triangle. So you can go and find these two and you realize that actually beyond isosceles, this is an equilateral. So you can straight away find angle ABC to be 60 degree.
what's the reason for
Base angle of isos triangle. Okay, then they say, can you then find the area of the triangle, which is very convenient because I already have two adjacent sides and the included angle. So I just do my half AB sine C. Okay, then what is the name given to this triangle? Equilateral. Okay, so sine rule and area of triangle is very easy to apply. You all just need to be careful with your calculation and accuracy. The interesting one is cosine rule. Because they always give you the formula in front, but if you don't know how to apply it, then you cannot use. My lesson until 9:35, right? Okay. Lucky today is Friday.
Can I do a thing?
Okay. Yes. Always, you always have to pick the two adjacent lengths. That means between this, and the angle in between. So if you choose the top one, let's say this is A and C, then you must choose the angle here. So it must always be like one corner, one letter V. These three. Okay? Can I? Yes. No need, because eventually this is a equilateral. So you just tell me equilateral already. Okay, last, yes.
How do you make the left cosine?
How do I make the?
Left like cosine, like the unknown one.
The unknown one cosine. This one is always sine. Sine rule always sine.
No, I meant like you like the trick you showed us yesterday.
Mm.
Turn like the unknown left from another left cosine.
One leg. Okay, later we'll address this. I want to apply cosine rule. Okay, so cosine rule, you see all the chunks all together 6 formula, but actually all you need is 1. So one form of it. So remember, cosine rule, there are 2 situations that you can use cosine rule. So if you cannot use cosine rule to find the unknown, it must be sine rule already. You only have these 2 rules. Okay, so the 2 condition. Condition number 1. If the triangle that you are given gives you 2 adjacent side lengths and the included angle, you can use cosine rule to find the 3rd unknown length. Okay, so condition 1 is if you are given 2 adjacent sides and the included angle. Then you know, oh, I confirm use cosine rule for this question. Okay, condition 2 is if they give you all 3 sides of the triangle. That means they give you these 3 lengths and they ask you to find any one angle. Any one of the angle. So find any angle. So this situation, we also use cosine rule. So you always access the triangle you are given. Do I have 2 adjacent sides and an included angle? Then use cosine rule. Do I have all 3 sides? Then use cosine rule. If neither, use sine rule. Yes.
But then don't you use sine rule for adjacent?
Sine, this one we will use area of triangle, right? Yeah, so sine rule is a different thing. Okay, so how to apply it? I'm not going to make you memorize the formula. I'm just going to teach you directly how to remember. Okay, then we try to apply. Okay, these are the 2 conditions. Just take note. So don't need to memorize all this. In fact, I never memorize any of it because the first formula there is given on the first page. As long as you know how to apply, you don't have to memorize anything. Okay, so here, this is the triangle I'm given. And the question says, can you find the distance between the market and the library? So they want you to find this length. What did they give you? two adjacent side and the angle in between. So I fulfilled condition 1. So I must use cosine rule. Okay, so the key thing is this. Take this to be like Pythagoras theorem. Okay, take this to be like a Pythagoras theorem but extension. So I want you all to see, this is the unknown you want to find. It is like your hypotenuse. So you will write ml square first. Okay, and knowing your Pythagoras theorem, you need to sum the squares of the other two sides, which is these two. So this is like Pythagoras theorem, right? But this is not. So you have to have the extension part. So you are required to subtract away 2 times the product of these two numbers, followed by the cosine of the angle opposite this, which is 130. So this is cosine rule. Okay, so whatever the case, the length that you want to find is always the hypotenuse on the one side. Yes.
It's not a right angle triangle.
Yeah. So that's why we don't stop here. We have this extension part. Yeah. But we use it, we try to remember it like how we will apply Pythagoras theorem. Okay? So with that, you don't want to work so hard and copy this whole thing all again, right? So you drop the square and put a square root throughout. Okay? Just by writing this correctly gets you 2 marks. If you calculate correctly, 3 marks. So cosine rule application in O level, they award you 3 marks for just writing this and the correct answer. So please be very careful in your substitution. This is a scorer. Please don't lose it. Some more they give you the formula on the front page. Still apply wrongly, I don't know what to say.
Get the long division.
What? Oh, they give you long division for what? Every question is different, what? Okay, so you end up having 1951.424. So they say 3SF. So 1950. We set the number before the decimal point. Meters. Okay, so just apply cosine rule properly and all shall be good. So there's 2 marks here, and then 1 tiny mark in the answer. Yeah, then some of you may ask me, sine rule and cosine rule can use for right angle triangle or not? Can. This one can use for any triangle. It's just Pythagoras theorem and Tuan Castle only right angle triangle. Sine rule, cosine rule, area of triangle can use for any triangle.
The last bit is not used because it's not a right angle.
Yes, correct. Okay, and it's 2 times of these 2 numbers. So it can never go wrong. Okay, this is always the included angle between them. Then of course we will slowly level up because the question will not be so clear cut and tell you use cosine rule, use sine rule, you must decide. So the difficulty is in the decision. Okay? Can? Next one. Okay, this one. Now, let's look at ABC. It's a triangular plot of land. AB is 9.3, BC is 5.6, BAC is 28, D is a point on AC, and AD is 4.1. So calculate BD. So this is the unknown. Zoom into the triangle that will give you your unknown or has more information. So what do you think we can use here? Cosine rule. Why? Yes, 2 adjacent side and the angle in between, the included angle, right? So take BD, the unknown, to be your hypotenuse. So BD square is equal to the sum of the squares of the other 2 sides. So just like Pythagoras theorem. But the extension part is minus 2 times the product of these 2 numbers. Okay, followed by cosine of the included angle between them. So that for 2 marks. So don't ever go and write the cosine as sine. I always have that. I don't know why. Okay, and then you square root the whole thing. Drop the square here. So you don't have to copy everything again. Okay, so go and do your calculation. They give you another 1 mark for that. is the greatest bargain of your life? 5.997. So 3SF 6.00 meter 3SF. Okay, part A. So every time you find something, quickly go and write in the diagram. Okay, next. I'm interested in finding BCA, this one. So I will look for the triangle that has most information. So of course it has to be the big one. I don't want the small BCD because not enough, actually enough or not? Not enough. Okay, so I'll use the big one. So you look at the big one. What formula can I use to find this question? Sine. Okay, because we have one pair here and then the other pair that I want to find. So let me establish that. If you are finding angle, put the angle on top of the ratio. So sine of the angle BCA over the opposite length 9.3. This is one pair. Yes. BD, because it doesn't give me enough info. Because if I choose this one I don't have. I need at least one pair known to me. Yeah. So the other one is the 9.3 I write already, right? Next one is the sine of 28 degree over 5.6. So go and write down the two pairs. One pair must be fully known to you before you can do this. So I cross multiply the 9.3. And then because I want to find the angle, right? There was a sign here. So I don't want to be so hardworking and rewrite again. So I just bring the sine inverse directly and inverse the whole thing. So I just have to write everything one time. 51.22 2292. Okay, so that will be 51.2 degree, 1 dp. Okay, but quickly copy into the diagram so that you can use it for later.
So for sine rule, you can use on both right angle and obtuse.
Yes, sine rule also can.
How do you know which side?
Depending on which one will give you the info that you want. Yeah, like the letter V. I have two adjacent sides included angle. Yeah, so you can only choose according to the given info. Okay, last one, I want to find area of triangle ABC. How? I don't seem to have enough info, right? I can find this. Half AB sine C, I can find this. But I cannot find the other one unless I have an angle. We have 28 at all. Okay, so we can find this. So let's find angle ABC by using 180 minus the 28 minus the 51.2292. So with that, you get, so small? Wait, 180 minus 28 minus 51.2292. 100.7708 degree. So this is the included angle. Do I have the two adjacent sides? I have, right? So I just half times 9.3 times 5.6 and then sine of this angle. So that's a 25.581 cm square, no, meter square.
Teacher,
Yeah.
random question.
Yes.
But you know, for the sine cosine angle,
Yeah.
you need to memorize, like, you know, the square root 3 over 2.
Yes, that one when we go A math, we must memorize the special angle ratios. Yeah, but that's a shortcut, so don't worry. Okay, so remember, based on whatever info you have, you use sine rule or cosine rule accordingly. Is that the last example? Okay, never mind. So anyway, this last example 3, I want to find BD. So I will look for the triangle that seemingly has more info. So for this triangle, which rule do you think we can use? Because I have one pair here, one pair here. So I will use sine rule in this case. So part A, BD over sine of the angle 102. And then it's 5 over sine of the 34.8 degree. So the idea is to look at your given and decide sine rule or cosine. So cross multiply, BD is sine 102 times this. So 8.5695, 3SF 8.57. Okay, quickly write on the diagram in case you miss the info later. 8.5695. Okay, now I want to find the angle BCD. This one. So I must obviously look at the other triangle now. So what rule should I use now? Cosine rule, right? Because I have all 3 sides. Okay, so why I ask you not to memorize any formula is because we always use one and then we manipulate using algebra. So where is the hypotenuse? The hypotenuse is the length you want to find. So this is the length by right, opposite the angle you want. So we take it to be the hypotenuse. So 8.5695 square is equal to the sum of the squares of the other 2 sides minus 2 times the product of these 2 lengths followed by cosine of the angle opposite. So this is the formula by right that we will use. You just memorize one application. Then now how do I isolate this? This is the one that I want to solve, remember? So I will bring this and this over to subtract. Okay, wait, let me finish this. Okay, wait, I really need to finish this. Okay, so this one, cosine BCD. So I already isolated the B square and the 7 square. How do I get rid of this part? Divide. Remember, you don't bring this over as a plus. You divide. So in this formula here, you will bring this entire thing down to divide. So that's why this is gone. Then how do you get the BCD? You cosine inverse the whole thing. So if you go to the previous page, you will realize this is the formula they ask you to memorize. But don't need. You just remember one application and then you reverse use it. So I very quickly give you the answer because this is almost the last. Cosine inverse, you will get 69. This one just copy here. 69.314. Which is 69.3. So area, I think you can find, right? Each part half AB sine C. So you will have AB sine this angle for the top triangle and then half AB sine C for the bottom triangle.
Yeah, so we can just apply half AB sine C
To any triangle.
If it's parallelogram, can we just use that one?
Can. But you need times 2 lah, to find the triangle of half. Okay, so this is the last part. You find the area of this triangle for this part, area of triangle for the second part and add up. Okay? So this weekend, can you all do the PMP? You have learned everything I can teach you for this chapter already. So go and apply it in the PMP next page. Example.